question says, use the data above to determine the following. Number 1, the reaction order with respect to hydrogen. Number 2, the reaction order with respect to iodine. And number 3, the overall order of the reaction. Now let us solve this problem. The data is on the board, as you can see, and the reactants used there, the substances used in the reaction are hydrogen and iodine. So I'm going to write my Rate's law equation. And remember, the Rate's law equation says that rate is equal to rate constant K times concentration. So I'll write it on the board here, which says that rate is equal to rate constant multiplied by concentration. Here, the concentration I'm going to use will be 2, the one from iodine and the one for hydrogen. So I have my hydrogen here, multiplied by iodine here. Now, I do not know the order of the reaction with respect to hydrogen and with respect to iodine. I am going to find them. That is why the data on the table here is given to us. So because we do not know the power, we are going to represent the exponents as x and y. That means we are going to find the values of x and y. I know that the order of reaction with respect to hydrogen here is equal to x, while the order of the reaction with respect to iodine is equal to y. And the overall order of the reaction is equal to x plus y. So all we need to do is to find the value of x, find the value of y. Okay, now how do we start? Now, this table shows that this experiment or the reaction between hydrogen and iodine was carried out in 3 different sections. The first experiment is the one called experiment 1. In the experiment 1, 0.031 molarity of hydrogen was mixed with 0.054 molarity of iodine, and the initial rate was discovered to be 4.920 times 10 to the minus 4. After that, the experiment was repeated again, which is experiment 2, and this were mixed, and this was the observed initial rate. The third experiment was carried out, this and this were mixed, and we got this rate. Now with this, we can find the values of x and y. I'm going to substitute rates and concentrations for me to be able to find x and y. Now I can decide if I want to find x. If I want to find x, I will look for 2 values where y will cancel out, because we cannot find x if we do not know y, and we cannot find y if we do not know x. You cannot have 2 unknown at the same time. So if I want to find x first, I will have to look for where the values of y will cancel out. Now how do I do this? I should know that I can call this experiment 1, which means this is my R1. I can call this my R2. I can call this my R3. Okay, now if I say R1 divided by R2, that is initial rate, the first one over the second one, I will have R1 all over R2 will be equal to, if I'm doing this over this, it means that I will do this over this. But if I do this over this, then I will do this over this. How do I go about it? My R1, I chose this as my R1, which is 4.920 times 10 raised to the power minus 4, all over my R2, which I chose to be this. Remember, this is a rate. So this is my rate 1, this is my rate 2, which is 1.476 times 10 raised to the power minus 3. If I do this over this, it will be equal to this over this. So it will give me this times this, which is 0.031 times This is concentration. I will multiply with this 0.054. That's 0.054. Divided by, I did this over this, so I'm doing this over this. Remember, it is rate equals concentration of H times concentration of I. This is concentration of H, this is concentration of iodine. So if I do rate 1 over rate 2, I will do concentrations 1 over concentrations 2. I know that my K will cancel out, so I'm not bringing in K. Even if I bring it in, it will still cancel out. Okay, now the second one, which is this 0.093 all multiplied by 0.054. Now, with this, I can now put their powers. Remember, my H, my concentration for hydrogen, bears power X, while iodine bears Y. This is my H, this is my iodine. This is my H, this is my iodine. So here is H, which is X. Here is iodine, which is Y. Here is H as well, which is X. That is X. And this one is my iodine, 0.054, which is power Y. Now if you look at this, you will discover that 0.054 power Y will cancel 0.054 power Y. So this will cancel out. Now that my Y is out, I can comfortably find X. How do I do that? If I press 4.920 times 10 power minus 4 divided by this, I will get this over this will give me 3. That is 1 all over 3. Am I correct? Equal to, if I divide this, I will have here as 0.031 power X, all divided by 0.093 power X. All I need to do now is to find my X. How do I find this X? I will look for a way to split this bigger value here. I'll break it into 2 so that something can cancel out. How do I do that? I will say 1 all over 3 is equal to 0.031 raised to power X divided by 0.093 is the same thing as 3 times 0.031 all raised to power X. Remember, I've not done anything. This 0.093 is the same as 3 times 0.031. I looked for the number that will use and multiply this, so it will give me this. When I found that number, I discovered that 3 times this thing will give me this. So I brought out 3 and this. So this thing here is the same as this. So I've not changed anything. And this simply means that 1 all over 3 is equal to 0.031 raised to power X divided by 3 power X times 0.031 power X. You can now see that this will cancel this. And by the time they cancel out, I'm going to have here that 1 all over 3, 1 divided by 3 is equal to, I've cancelled out here, I have 1 left up, divided by 3 raised to power X. This is what I have. If I invert this, it means that 3 divided by 1 is equal to, this one goes up, 3x over 1. So this is what I have. Therefore, simply means that 3 is equal to 3 raised to power x. And if 3 power 1 is equal to 3 power x, remember the power here now is 1. Simply means that 3 raised to power 1 is equal to 3 raised to power x. Therefore, my x is equal to 1. Remember, this thing simply means 3 power 1 equals 3 power x, because the power here is 1. If I equate the basis, I have it that x is equal to 1. That's what I have there. I have gotten the value of my x. I can now find the value of y. Let us proceed to finding the value of y. How do we find y? The same method. I will look for the two values that can eliminate x so that I'll find y. Let's do that again. We can now take, remember, x is for iodine, x is for hydrogen, y is for iodine.
Action.
Alright, we are now going to find the value of y. We have found our x and we got 1. Now we are going to find y. And for us to find y, we are going to look for the values of x that will cancel out. That is, we'll choose where x will have equal values and choose where y will not have equal values. Remember, hydrogen bears our x. Remember, we are working with rates. Equals rate constant times hydrogen concentration times iodine concentration. And our hydrogen has power of x, while our iodine has power of y. So in order to find y, we will eliminate x. How do we eliminate x? X is the one of hydrogen. We are going to look for two values of x that will cancel out, and that is this and this. So we are going to use this and this so that this divided by this will cancel out. And see, we can now be able to find y. Y is for iodine, x is for hydrogen. So here, this and this are equal. So we use these two values, which means we also use here and we also use here. So I can use this and this now. I can say 4 points. If I like, I can say this over this, or I'll say this over this. Anyone you like, you are correct. But if you are using this over this, you must use this over this. But if you are doing this over this, you must do this over this. So let's try this method. Let's use this divided by this. This over this. That means my rate 1 point, this is rate. My first rate, which is 1.476 times 10 raised to the power minus 3, divided by the second rate here, that is the third rate, 4.920 times 10 raised to the power minus 4. Here, sorry, this is minus 4. Is equal to the rate constant multiplied by the concentrations. The rate constant will cancel out, so no need showing it here. I have my two concentrations, hydrogen concentration and iodine concentration. Hydrogen concentration and iodine concentration. Remember, for this rate, this is concentration of hydrogen, this is concentration of iodine. For this rate, this is concentration of hydrogen, this is concentration of iodine. So for this rate, which is this is my hydrogen concentration, which is 0.093, and this is my iodine concentration, 0.054. I'll put the respective powers. Hydrogen has my power of x, iodine has power of y. Now for this rate, which is this is my hydrogen concentration, 0.093. This is my iodine concentration, which is 0.018. Hydrogen has power of x, iodine has power of y. So as you can see here, the x will cancel out because they are equal. And I have this over this, which will give me, if I punch this divided by this, then I will have 3 all over 1. That's what it will give me. Equal to, I have 0.054 left. All raised to the power of y. Raised to the power of y. Divided by 0.018 raised to the power of y. So I have to find the value of y. Just as we did earlier, all we need to do now is very simple. What do we have to do? All we have to do is, what are we going to use and multiply the lower value to get this higher value? If I find the number that will multiply 0.018 to get 0.054, I will use that number and split with this in order to be able to cancel one of them. So how do I do? I know that 3 multiplied by 0.018 will give me 0.054. So I'm going to eliminate 0.054. That means I'm going to have this, which is 3 all over 1 is equal to, this thing here is the same thing as 3 times 0.018, all raised to the power of y. Both raised to the power of y. I have not done anything. This power y is this power y here. This 0.054 is the same thing as 3 times 0.018. I looked for a number that will multiply this lower one to get this. And as soon as I got that number, I used the two of them to replace this. Now divided by this one under here, 0.018 raised to the power of y. And you know, according to indices, if I have AB raised to power 2, is the same thing as A power 2 times B power 2. So I'm going to open this bracket. I have 3 and this. If I open up, I will have 3 power y times 0.018 power y. So what I will get will now be 3 divided by 1 is equal to, opening this bracket to give me 3 raised to power y multiplied by 0.018 raised to the power of y, all divided by 0.018 to the power of y. So you can see this can cancel out. So I have with me here 3 over 1 is equal to 3y. I can still say over 1. From here, you can simply see that we have gotten the value of y as well. And from there you have 3 is equal to 3y. And what is the power of this 3 here? It is 1. Therefore, my y is equal to 1. I have gotten the values of x and y. In summary, my x is 1 and my y is also 1. Remember, 3 here, the power is 1. This is 3 raised to the power 1 is equal to 3 power y. So y is 1. Now, I have gotten x is 1 and y is 1. I can now answer the question. And those questions, question number 1 says, find the order of the reaction with respect to hydrogen. I can find it. Now, my rate, let me rewrite the equation. My rate, which is equal to rate constant times hydrogen raised to power x and iodine raised to power y, simply means that now that I have the values of x and y, I can rewrite it by saying that rate is now equal to K times hydrogen to the power of x, which is 1, times iodine to the power of y, which is also 1. So, number 1 question, we are going to answer it. Number 2 and number 3. The first question there says, what is the order of the reaction with respect to hydrogen? With respect to hydrogen, as you can see, the order is 1, and 1 simply means first order, which is first order. Number 2 question says, what is the order of the reaction with respect to iodine? With respect to iodine, the order is also 1, which is first order as well. And number 3 question says, find the overall order. The overall order is the sum of the orders. I have the overall as 1 plus 1. That gives me 2. And 2 here means second order. Overall order is second order. And that is the answer. Thank you for watching. In the next video, I'm going to still give one more example of this.